All right, people. So we're here to do a little Maths paper one crash course. Please share everywhere. This is free. Obviously, you've seen it online. So what we're really gonna do is focus on some sample papers, do some questions, and let's see if we can get at least 3 sets of 45 questions done. This is going to be really nice for you because I'm going to show you all the tips and tricks that you can use in an AdMaths exam, right? So I know AdMaths, when I do AdMaths, this is the live with the least amount of students online because AdMaths, not many people doing AdMaths. People who do AdMaths will probably go on to do pure maths engineering, that kind of thing. So share it up with your AdMaths crew. Tell them, hey, come let me see if you know anything in AdMaths here. Your bio's food, very nice. Somebody else telling me there's an error in one of the bio questions. I hope not. How much time do you have for the exam? I guess you've seen since it's 45 questions, this thing is less time now. It's the same amount of time, but the questions take longer to do in AdMaths. IT was good, nice, nice, nice. So let's press like on it now. Let me get down into business. Let me get down into business. So there'll be a lot of people who would rewatch as well. So shout out to all the rewatchers, people who watching in the future. I always like to make sure I put this number here for those of y'all who would be looking for online lessons. At the Student Hub, you could WhatsApp this number +1-868-310-1306. You want to get hit up this number on WhatsApp to register for lessons in the Student Hub. Oh, you're not seeing my screen. I'm gonna have my screen. So +1-868-310-1306. That's what you want to do, right? So by was a lot of repeats, same as IT. Very nice. So we're hoping for AdMaths to follow suit. So there we go. So these sessions paying off then. These are multiple choice sessions doing well. The expression x minus 2 is a factor of, well, we know we need to substitute +2, right? According to the factor theorem in all of these. So best bet is to just use your calculator to quickly put +2 in all of these. So it'll be like 4, and I'm going to put 2 in this, 2 to the power of 4. 4 by 2 to the power of 4 is 16 minus 2 by 2 to the power of 2 is 4. Y'all understand what I'm doing? Minus 56. And I get 0 one time. So A is indeed the answer. So anytime you have a question like this where you have to check the factor in the questions, put a little asterisk on the question paper. But you already found that A is the answer, right? You understand what I'm saying? You don't need to go and check the rest yet. Save your time. Go and do the others. When you finish your paper, you'll come back and just verify that all of these not giving you a 0. That's okay. Important little tips that could save you some time in the exam. And maths paper one could actually like, actually be a scene where you want to save the time. AB plus 3C minus 3B minus AC. What happens with this in AdMaths, this group in question, is that they're not in order. So you want to rearrange them. So I'll probably put AB minus AC plus, no. B has a negative. So I'll put minus 3B plus 3C. So this came across. So I'm going to factorize out A out of this, right? So I'll factorize out A out of this. I'll get B minus C. Then I take this B minus C and put it back here. That's how this works. And what I get factorized out of this to make everything right with the world, definitely a negative 3. You'll see in that. And you'll end up with A minus 3 by B minus C. Well done. Well done. Well done. 868 Shalia Cyan ID. So this one is D. All right, I'll be grinding for a little while here. I don't know how long this may take, 2 hours, 3 hours. Which of the following graphs best represent f of x? Well, we need to examine the roots. That's what we're looking at. So we have a root at x is equal to 0. Because if you equate this equal to 0, you'll get that meaning the roots here now, these things. We need to see which root you're looking at. We also have a root at 1 minus x is equal to 0. This is negative x is equal to negative 1, or x is equal to 1. So this can't work because this is negative 1. This one may work. We'll come back to him. This one may also work. This can't work because it's negative 1. So which one is it? We get in roots at x is 0 and x is 1. The only thing left to see is to determine whether the curve will give you a maximum point or a minimum point. And from this, we can deduce that the curve will actually give us a maximum point. How do we know that? Well, if we expand this out, we get x. If you expand the x by we get negative x squared. This means the coefficient of x squared is negative. So since the coefficient of x squared is negative, we expect a curve that looks like this. The answer is B. Number of visas VX issued by embassy annually is given by this. This is a very repeated question. Least number of visas issued in a particular year X is. So they want the minimum point of this quadratic. So one of the fastest things you could do, I'll be showing you lots of tricks in this thing, right? Is whether you have a Sharp or a Casio. I know one or two exam centers stop students from using their Casio, which is absurd. Press mode, press equation, go on 3, and quickly put in the coefficients, because what I'm looking for is the minimum point. I'm seeing that it doesn't even cross the x-axis because there's imaginary roots. So the minimum value of x is 3, but that's not what I want. 3 is not even here. That's the x value. I want the y value at the minimum point. It's 9. So the answer is B. How is that? So in other words, I want the k when I complete the square. And k is 4ac minus b squared over 4a. So if you substitute this, a, b, c being these numbers, a being 7, b being negative 42, and c being this, you would be able to get the value here. This will work out to be equal 9. Yes, another way to do it is you can find h. H is b on 2a, and you will get h to be negative 3 when you put b on 2a. Yes. Yes. However, you want to substitute positive version of this because the x is negative h, so you want to substitute minus b on 2a. So this negative 3 into this. So you'll put negative 3 into this and this as the x, and it will also give you 9. So there are 3 ways to do this question. I showed you the fastest ways to use your calculator. And then you can put an asterisk on it so you could come back and use a calculation method just to double check. Nobody's watching your working, they're only watching the answers, right? The roots of an equation are, once again, I could verify this on my calculator very easy. Still in quadratic mode, so I could just put in the 5, the 6. I'm showing you all the tricks that people keep with the calculator. Showing you all of it. Yeah, my class and the student I would know all the different calculators, how best you can use a calculator to solve all these. You would see, you'll begin to become almost terrified with the power. If this is the first time you're seeing this, by the time we do these 345 questions, and I show you all the different ways you can use a calculator, there's no way you're getting under 40 or 45 in this multiple choice. Anyhow, so you're seeing what happening there. We saw negative, this was positive and it turned negative. It means the roots are real and distinct. Real and distinct. C is the answer. So that's the calculator. How do you work this out? Well, you use something called the determinant. So you want the b squared minus 4ac. You want to watch this number and see what happens. So b squared, that's 6 squared minus 4 by 5 by, or the discriminant, sorry, by minus 2. So this is 36, 4 by 10, 40, 36 plus 40. So this gives me 76. Now, you don't really care about the number, to be honest. You just care about whether the number is positive, negative, or 0. So if the number is positive, it's real and distinct. If the number is negative, it's not real. That's all. It's not real. It's also distinct, but it's not real. So imaginary. And this is real and distinct. And if this is 0, then it's real and equal, or repeated in some cases. They will put repeated. So 0 is the only exception where the roots would not be distinct. The root's always distinct. Distinct just means two different roots. All right, so that's enough knowledge, and that I showed you the calculator way, and I show you the how to calculate it using this is called the discriminant. Discriminant. This is the part in the quadratic formula that is under the square root sign. That's why it's so important. It depends on whether this is negative or positive, whether we can figure out the roots, you understand? Or how we figure out the roots. The set of values of x for which, all right, so this is an inequality, so you're going to bring across the 10x, bring across the 7. Now, I'm not too sure how many people understand what I'm doing here. I'm doing a crash course level words of work. I might not even keep it up after the exam. X is greater than 4. Hold up. I get distracted talking me. So I'm doing a crash course level work of worth of work. So we're going to be doing 45 sets of questions. 3 sets of 45 questions. Well, I can't talk, but anyhow, and by the time you all finish this, going through this, going over this is going to leave you in a really nice place for the ADMAT exam. I might even do an additional sample right before the ADMAT exam if I get the chance, right? So what happened here? The thing is, yes, I was following the rules of linear equations, bringing stuff across, solving as I go along. But I had to bring across the 5 and it's negative. The rules is anytime you divide or multiply, by a negative number, the sign must switch direction like this. So it's actually x is less than 4. C is the answer that we are going for. What's another way? I'm trying to show you all different ways to solve, because when you finish your multiple choice, you want to go back to using different methods to solve it. Another way is to substitute. So this one is saying x is greater than 4. This one is saying x is less than 4. Fine. If this is saying x is less than 4, let's substitute a number like 3 into this and see if it works. 5 by 3 is 15 plus 7 is 15 plus 7 greater than 10 by 3 is 30 minus 13, 30 minus 13, 15 plus 7, 30 minus 13. Yes, 15 plus 7 is greater than 30 minus 13. This works. No, that's not a foolproof method. You miss it, so you don't start off with that. That's just a way to verify if your answer is correct. All right. All right, like keep pumping. By the way, your calculator can also solve this. Calculator can also solve this. All right, I could solve the linear equation part of it. Yeah, let me leave it alone. Excuse me, I have a kind of cold here that's still coughing and thing. It has some calculator videos for the sharp up here. You can look curving string as sharp, but not too deep for advanced student. The calculator could solve it if it was an equal sign here, so you can figure out that x is equal to 4, but you still need to know which direction. The range of values of x for which f5x plus 6 is less than or equal to x squared. Right, so your calculator could definitely solve this one. So this is a quadratic inequality, right? So bring everything across, or bring everything across on this side, you'll get 0 is. So a lot of people would do this, but this is a little weird to have the inequality sign here, and if we had to bring it across, they could get lost in transmission. So let me don't be afraid of the negative sign. Let's bring the x squared across and face the music. We have this. We're watching this, ladies and gentlemen. So what I'm saying is, yes, your calculator could very quickly solve that. You press mode, you press inequalities. So I went down actually, right? I went down and I pressed inequalities. I'm going to choose quadratic. I'm going to choose what I'm seeing here. I'm seeing less than or equal to. So that's the fourth option, number 4. Everybody is seeing and understanding. I told you I'm going to show you every trick in the book. -1, 5, and 6. No one shows you how to use your calculator like this. I'm showing you everything, right? So x is less than or equal to -1. It's two separate situations, so I don't want this or this. I want two separate situations. Notice how there's a comma here. I want my x to be less than or equal to -1, or my x to be more than, notice how the open spot is facing the x, more than or equal to 6. You still need to know how to read the notation, right? And that's B. All right, so how do we do this otherwise? Well, you solve it. So this is -6. We want two numbers that will add to give me 5, but multiply to give me -6. So that is plus 6x and minus 1x, right? Plus 6 is less than or equal to 0. And then you factorize. You have x into negative x plus 6. And you have negative x plus 6. We just need a 1x. We just need a 1 plus 1. So we have x plus 1, and we have negative x plus 6, or 6 minus x, some of you all may have. It's less than or equal to 0. So the roots for this would be x is equal to -1, or negative x plus 6 equal to 0. So you're seeing what that means, right? That means x is equal to 6. So we have these two roots, and then what you're supposed to do is draw the curve, and you know the curve will look like this, because this is negative, so it's a maximum curve. So after you've drawn the curve, you need to put in the 2 points. So one is -1, one is 6. So I put it in this order. Negative will go left, positive will go right. And I deduce when this is, I want it to be less than 0. So this is the x-axis, right? Everything below this axis is less than 0. Everything above is more than 0. I want it less than 0. So less than 0, notice the line down here is less than 0. So what I've told my class to call this is the wings. Right? This is the wings. When it's in between, we call it the sandwich. So this is the wing. So you know you're dealing with two situations. You're dealing with a situation where x is less than or equal to -1, or x is more than or equal to 6, which is also B. So that's the long way. I'll show you the calculator way. Let me keep pumping. If you all understand that type, I understand. So far, so good. See now to solve these things. Some of you all is revision, some of you all from my class, because I know I sent the link to my class. Some of you all fall asleep while you're just done bio and IT, or you need to sleep. But or you're gonna be watching this in the future. Wake up. If f of x is equal to 3x minus 4 and f g x is equal, I'll even this out. Should I? They removed functions from AddMaths now. Let me just do it for kicks, right? Because it can help a little in the maths multiple choice anyway. So f of x is this, f g x is that, then g of x is what? So how do you solve this kind of question? This is like a compound. This is like a compound function, composite function. And then we have one of the functions, but we need to get this function. So there are a few ways we could do. We could solve this. If g of x is equal to x, f of x is equal to 3x minus 4. So there's a substitution method that we can use, and there are other methods. What method do you suggest? Now, g of x means the g came first. We did g of x, then we substituted it into f, and we got x. So when we substitute g of x into x, we're supposed to get x. Well, I think probably the fastest method is the substitution method, where you just substitute the answer. I already could visualize substituting this. If this is g of x, substituting it into f of x, I could already see this not going to help. The x going to end up underneath. This looks really promising, so I'm going to try this one. So I'm going to say 3 by x plus 4 over 3 minus 4. Oh, there's a little problem here. The 3 cancels. Oh, yes, it does work. So I get x plus 4 minus 4, and I get my x. So that is here. That's the fastest way. So the fastest way to do this question is just substituting the answer instead of doing the algebra behind it. So you just look at the answers and this. I want g of x. G of x is the first one. G of x into f of x makes f g of x. So I'll check which one of these substituted into f of x will just make the x that I want. All right, you all understand? The tables below show the ordered pairs for two functions, f and g. Okay, the value of g inverse of f of 3. So you need to do this bit by bit. So you need to do f of 3. So let's do f of 3. F of 3 means substitute 3 and then find f of x. So that's going this way, right? So f of 3, if x is 3, f of 3 is equal to 2. Y'all understand what they're telling you there? Yes, class. And then, so this is 2 now. So anyway, so I'm seeing this, I just need to see 2, right? I want g inverse of 2. So obviously, I'm not going to pick this one and go like that. That's wrong. Why? Because it's inverse. I need to go backwards. I need to use this one. You understand the trick in this question? So g inverse of 2 means I'll be going backwards like this. So 5. This used to be a really tricky question. Everybody used to get this question wrong. A function h is defined by h of x is equal to 5x plus 2 expressed in terms of a, h of 2a plus 3. Fine. H of 2a plus 3 just means that I need to put 2a plus 3 in place of x. So now I'm seeing 10a plus 15 plus 2, 10a plus 17. The answer is C. A function f, real function, is defined by f of x is equal to 2x minus 1. The function f2 is defined as, well, this just means substitute f of x into itself. So this is f of x. That's what this is. So this means put the 2x minus 1 back in where I'm seeing the x. You understand? So now I'll have 4x minus 2 minus 1. So this is 4x minus 3. That's him there. So they remove functions from the syllabus. But certain ways algebra can overlap with functions. So I would still advise handling your functions questions when you're doing your past papers. By the way, knowledge. All right, so we after that, let's do this question. The root of 3 minus 27m is equal to what? The nth root. So they want you to simplify this. Well, it's clear to me that they want you to put this as 3 as well. So this is 3 times 3 to the power of 3 by m. So far, so good, everybody. Now I need to group this up. But before I group this up, this is really 3 times 3 to the power of 3m. This is a power to a power. When you go in power to power, you multiply. Right? And now this is multiply, same base. So we add. So this is 3 to the power of 3m plus 1 so far. So far, so good. And then there's a square root sign. Square root means fractional power. Well, actually, it's not square root, it's nth root. Still fractional power. But if the denominator of the fraction will be n. So this is really 3 to the power of 3m plus 1. And the fraction is n. The nth power. So the answer is A. Is there a way to figure this out if you forget how to do this in the exam, you forget indices and you're not too sure and you're panicking? Yes, there's a way to do it. There's a way called, there's two things. Substitute in the answer. I call that theta. Where you substitute the answer into the question and you can do it. And then there's substitute in a number. Instead, so that's like I teach my class like two ways to look at this. Meaning, here's what I mean. So, like, you forgot how to do the indices, you forgot how to do powers. Pick a number for m and n, and pick numbers that are simple. So, like, pick numbers like n will be 2, let's say the square root, and m would be, let's say, 1. Now I have the square root of 3 times 27 to the power of 1. Work that out in your calculator. The square root, go back into normal mode. the square root of 3 times 27 to the power of 1. So that's just 3 times 27 is 9. And now I'm going to, you all understand what I'm doing? Now I'm going to check the answers with n is 2 and m is 1 and see which one gives me 9. So if n is 2 here, this is 2. Yep. So if n is 2 here and m is 1 here, this is 3 plus 1. This is 3 squared. This will end up being 3 squared, which is 9. So that one works. Now, if I put n as 2 here and m as 1, I will get 3 to the power of 5 or some kind of thing. This does not work. Once again, if I put squared here and 1 here, this is a really big number. This doesn't work. This doesn't work. So you can substitute in numbers to verify. Showed you another way how to do the question. Please make note of these little techniques because sometimes it might save your neck in the exam, right? 8 plus, you want to get everything correct in the paper one, 8 plus square root, because if you didn't get it correct, people in my class will get it correct. 8 plus the square root of 5, 2 minus the square root of 5 can be expressed as 1. All right, so we need to multiply 8 by 2. So we get 16, 8 by negative 5 minus 8 by the square root of 5. Square root of 5 by 2, you'll have 2 plus the root of 5. And root of 5 by the root of 5, that's just negative 5. Can your calculator do this? Of course it can. So the cashier can literally type this in and it will give you the answer. So 8 plus root 5, 2 minus root 5, 11 minus 6 root 5. The answer is A. 16 minus 5 is 11 and negative 8 plus 2. You could think of the root 5 as like an x. You don't interfere with it, right? It's like you can almost think of it like a little variable that we're not interfering with. So this is minus 6 root 5 in the end there. So long way, short way, I showed you 2 ways to get the answer. It will get easier than that. The value of 2 to the power of z, where z is equal to 5 plus log 2, 3 is, so they want 2 to the power of 5 plus log base 2, 3. Once again, your calculator is just going to mash up this because your calculator can do logs in different bases. The sharp, there is a long way to do it on the sharp. So 2 to the power of 5 plus, because a lot of the sharps don't have multiple bases on the logs. 3, and they're telling me that the answer is 96. So you literally plug this into your Casio and walk away with the answer. All right, but if you couldn't, what would you do? Well, this is 2 to the power of 5 multiplied by 2 to the power of log 2, 3. Now, when you see 2 to the power of log base 2, that's like you're going up and you're coming down. You can just cancel these two things and write 3, right? And 2 to the power of 5 is 32. Could double check 2 by 2 by 2 by 2 by 2. And then you need to multiply this by 3, you get 96. 3 will just fall. All right, is there any other way, Nadia? I'll show you the 2 easy ways to do it, calculator and actually doing it out. The expression, which when simplified, once again, your Casio is just going to mash this up. You may need to watch the factorization to figure out which one is which. Root 5 minus 1 all over 1 plus root 5 equals, so this is 3 minus root 5 over 2. In other words, half of 3 minus root 5. Half of 3 minus root 5, D is the answer. So how are you supposed to do this then? Well, you have to rationalize. Doing it the long way. So you do the calculator way and you go on to the next question and then you come back and you double check with the long method. So you multiply by the conjugate of the denominator. So it's just gonna get worse, bro. Let me tell you one time, it's just gonna get worse. It's just gonna get worse when you see the amount of different things I will. The sharp could do something, but the method to do it on the sharp rel annoying and thing. So anyhow, root 5 by 1. That's root 5. Root 5 by another root 5, that's like negative 5. Negative 1 by 1, that's negative 1. And negative 1 by negative root 5, that's like positive root 5. All right. Okay. And this is 1, well, this is like difference of 2 squares. So you'll end up with 1 minus 5. So you're going to end up with 2 root 5 minus 6 over negative 4. So I could pull out, I could firstly say 2 into everything, right? That's a U decision, Zara. That's a U decision. The Casio is a real big help for the exam. It's a massive help. But I didn't know if you could get it in time for the exam. When is it, Maths? But I was telling you to get it so long. If you come on my channel so long, I'm saying to get this. So I could pull out the half, but I still have a negative. So strongly signs and make this positive and make this one negative. So there's a little tough arithmetic here for some students to see how to manipulate the negative sign to get it to look like one of the answers. So this is where the Casio would come in really handy. You would get a real nice help in seeing that. 2 to the power of negative 1. I just see my brethren here, not register. Xavier, is he seeing everything goodbye? Goodbye. How was them exams? Xavier here. 2 to the power of negative 1 over 8 to 1/3 simplifies as 8. Well, once again, your Casio just going to rip through that. I tell you, it's not going to get better for non-Casio users. Non-Casio users going to watch the stream and be very angry. 8 to the power of a fractional power, not a problem. 8 to the power of fraction 1/3. Yeah, because you're doing that normal things, you get a quarter, right? But still, if you're really good in that maths, it's not a problem. You'll be able to do the question. So 2 to the power of negative 1 is really, let's separate it, divided by 8 to the power of 2. That means the cube root of 8, which is really 2. We know that's 2. So this is 2 to the power of negative 1. That means 1 over 2 divided by cube root of 8 is really 2. So this is a half multiplied by flip it around, which is a quarter. So it's not bad. If you are boss in maths, you could figure it out without having a Casio or anything. But having the Casio really does help and give you a nice added comfort that you know 2 ways to get the answer. In a geometric progression, each of whose term is positive, the 5th term is 45 and the 7th term is 5. The 6th term is, all right, so if the 5th term is 45 and the 7th term is 5, it's a GP. And we're using stuff like common ratio. So the 5th term, AR to the power of 4, right? Because ARN minus 1, TN. And the 7th term, AR to the power of 6. So what we're saying, AR to the power of 4 is 45. And AR to the power of 6 is 5. So it's going down. So we expect a common ratio. That's a fraction, right? And what they want? They give us the 5th, they give us the 7th. By the way, I can do this by just elimination. I can do this by just guessing. 45 divided by 3. I can do this by just guessing. I could watch this and guess because they gave us the 5th term. You understand? And the 7th term. I know they're asking me about the 6th term. And the 5th term is 45. And the next term is 5. It can't be 40. It can't be that it went to 40, then it just jump all the way to 5. Remember, this need to go down by a common ratio, something divided then, or multiply. And I see like it multiplying by 1/3. And I get 15. And then I multiply by 1/3 again, and I get 5. So that's the fastest way to do this question. Just watch the 5th term, stay woke now. You realize 5th, 7, they were the in-betweeners. It's easy to just watch the answer and pick out the correct answer. So what's the long way to do it then? Well, what you're supposed to do is a kind of division vibe. So you're supposed to say, okay, call this equation 1 and equation 2, excuse me, and say equation 1 divided by equation 2. So think about it, you end up with 45 divided by 5, which is 9. And when you divide these two, the a's will cancel. And you'll get, I said 1 over 2, my bad. I should have said 2 over 1. but fine, you'll get r to the power of negative 2. If I divided the other way around, I hope I could survive my voice. 2 divided by 1. Either get 5 over 45, either get 1/9 is equal r to the power of 2. Some people will see it positive like this now. The other one I'll get -2, which is still get the answer. Anyhow, so the r has to be the square root of 1/9, so r is 1/3. And I'll only use the positive since that's the only one that works. So r is 1/3. And once I know r is 1/3, I could just divide this by 1/3 to get to the 6th term. So either way, understanding how GPs work would help you to really go through this question really fast. Some of the odd numbers, 10 to 50. This is always work out to be 600. So if we work in odd numbers, 10 to 50, there are 40 numbers here. Odd numbers, there'll be 20 of them. We'll be starting on 11 and going all the way to 49. So the first term is A. The common difference is 2. So A is 11, D is 2, and you find the sum. Excuse me. Sorry for coughing and thing earlier. I'm just trying to live here. I'm just trying to live. Find the sum to the 20th term. What is the formula for S of n again? Why somebody's always giving me this formula in class? Sum of here it is by AP. N over 2 to A plus n minus 1D, n minus 1 into D. So yeah, you just hit them that shot and you roll out. This is the longest way you can do it. There's a first and last method that's a little better. So what we want is 20 terms. Just remember it's half the terms. So it's really 20 divided by 2 by 11 is the first term plus n minus 1. So this is 19 by 2. And hopefully that gave us 600. Hopefully we are nice looking 600 there. 10 by 2 by 11 is 22 plus 19 times 2. 19 times 2, 600, right? So what's the faster way to do this? Hold on, my children, just storm the room. All right, yeah, we're back again. So what's the short way to do this? What I was saying, right? The first and last term, add them up. So we have 11 and 49. So 11 plus 49. And how many pairs of these we'll get? Because you'll have 11 plus 49. In other words, what I'm doing is 11 plus 49. The next one will be 13 plus 47. You'll understand? And this pairing situation will go on until they meet the middle. So if there are 20 numbers, there are 10 pairs. There are 10 pairs. So it's 10 times that. And as simple as that, you'll get the answer. And all these pairs add up to the same thing, right? 60, 60. So 10 times 60 is 600. So yeah, so that's the fast way to do it when you have the first and the last any term. Now it wasn't 10 and 50, it turned out to be 11 and 49, but same thing. Can you use summation on the calculator? We don't really want some of our series, we have some of our yeah, I guess you could probably set up a summation, but that's overkill. The first 4 terms of convergent geometric progression is given by 500. Right. Sum to infinity. Sum to infinity. What is it again? S infinity 1 minus r. Right? What is sum to infinity again, boy? A over 1 minus r. A over 1 minus r. We have a fraction. right? This is the 500. The first four terms is 500. So we're looking at 500 and 500 over, so 200 over 500 is 2/5. So the 2/5, yep. So it's 1 minus 2/5, and that's our final answer there. 500 over 1 minus 2/5. 500 over 1 minus 2/5. So 1 minus 2/5 is just 3/5. D. So this is the way to go. A long distance runner runs the first kilometer of a race. So once again, we AP land. A lot of these things is just AP and GPs. Progression, series, something. Finds that his speed drops steadily so that each kilometer is taking him 12 more seconds. Time taken to cover. So we had to change it to seconds and then change it back to minutes and seconds. Fine. That's the main task in this question. We're making this so long. So 3 minutes. So 180 plus 45 is 5 and 2 and 2. 2 to 5 minutes is the A. That's your A. And your common difference is 12 seconds. And you want the time for the first 12 terms. So in other words, you want the sum to the first 12 terms. So it's 12 over 2 by, what it is, 2A, 2 by 225 plus n minus 1. So n minus 1, 11 times 12. So we found the sum of an AP. Each kilometer is taking him 12 more seconds. Each kilometer is 12 more seconds. So I'm adding 12 to every one. Time taken to cover the first 12 kilometers. You could use the A and L, but you had to find the L. So best you just put in this whole thing. So simplify, this is 6 by 2 by that is what? 2 by that is 450 plus 132. And there's still going to be some conversion. There's a way to convert from seconds to minutes to minutes and seconds on the Casio, you know. I just forget how to do it. It's pretty quick as well. 3492. Oh, I'll have my Casio here. I'm watching on the physical Casio, and I might figure it out a little faster. It might help you in the future. Let me see if you could just figure it out. Oh, yeah. I'm not finding it. Wait, boy. Is it this one? It's somewhere there. It's somewhere there. Moon. It's somewhere there. It's somewhere there. There's a way to do it. And I used to know how to do it. I probably do it on a YouTube video already. I'll go and find it. I forget. But anyhow, this is easy to do. This is the answer we got. We want to divide this by 60. And when we divide by 60, you could get it like this. And just do 58.2. So 58 and a fifth. So 58, 12. There's another way to do division on the Casio. I'm just showing you some quick things that might help you all in the future. Let's just go back up. You could remain the divide. So you could alpha divide by shucks, I think I'm in the wrong number by 60. I think the wrong number is in the answer. So what would happen? What was the number that we had from before? 3492. 3492 alpha this and you divide by 60. So it will give you 58 remainder 12. You understand? So 58 minutes, 12 seconds. Might help you in the future. You never know. All right, enough for that question. The line 7x minus 4y plus 25. So the first people go a little slower, the second people go faster, and the third people go fast. 7x minus 4y plus 25 is equal to 0. 3x minus y minus 5 is equal to 0. Intersect at the point P. Fastest way to do this question might be to substitute 5 and 10 in and see if it, now substitute each point in and see if it satisfies each one. So if I substitute 5 and 10 in here, substitute in the answer, well done, Sita. I'll get 35 minus 40 plus 25. That just makes no sense. That does not give me 0. You can see that not going to give me 0. Try negative 1. So I'll get negative 7 minus 32 plus 25. Still, I'm not getting 0 here. Understand? This is the fastest way to do it rather than having to solve the simultaneous equation. The student hub, I think we sold out to. So might have to borrow one for real. A lot of math students have the Casio. So if you have a maths brethren who not doing hard maths, you could probably borrow it. And practice it and make sure you know how to reset. Those of y'all who going to buy it last minute. Make sure you know how to reset the Casio. Or you switch it in a mode and you don't know what to do. Press shift and 9 and then follow the instructions. Clear all, yes. Reset everything. So yeah, practice using it and go with both the calculators, just in case you get stuck with the Casio, because I know people can get stuck with it. Mode, when you go in some mode, some people don't know how to come out the mode. So you're in a mode here and you're just there and you don't know what to do and you're struggling with your life here. Well, you're supposed to just press mode and press 1. So practice it. Make sure you have understand how the math. Sometimes you lost the setup. It's supposed to be on 1 math IO. Let's give you this. Let's give you the setup that I use. All right, where was I? So negative 9, 7 by negative 9. Them numbers too big, boy. Negative 63. Negative 32, 4 by well, what I'm putting in negative 32. Is that gonna work? That's something like that too abstract. That'll get me a big positive number. Nah. This is okay. So the answer will be D, hopefully. So we'll have 7 by 9 is 63. Minus 88, because that's 4, plus 25. Yes, sir. This is the one. So this is the only one that work with the first equation, and it had to work with both equations. So this is the answer. Substitute 9 in here. 3 by 9 is 27, minus 22 minus 5 is also equal to 0. So D works for both of them. That's the fastest way to do it. And I take some time because I was talking to you all and but you all could very quickly just substitute and go through these kind of questions. So yes, this is a classic case of using theta, substituting the answer. One of the most deceptive things in a multiple choice that some people take for granted is the answer is in front of you. You ever stop to think how ridiculous that is? The answer is there. The answer is in front of you. So if the answer is in front of you, one out of these 4 things, I mean, the line through points P, K2, and Q, is parallel to the line. What's the value of K? So they're asking you to find the gradient, in other words. So if I rearrange this, I would be able to pick out the gradient. If this is rearranged, understand that when the 3x comes across, it will turn negative. So the 21 will switch, but we're not really interested in that. This is what we're interested in. This is the gradient. And they said it's parallel. So it means negative 3 must be equal to, if we find the gradient of this. In other words, it must be equal to 8 minus 2 over 6 minus k, which is 6. And if I bring across the 6 minus k to meet the negative 3, negative 3 by 6 minus k, you understand? I equated the gradient. Y2 minus y1 over x2 minus x1. Nobody need to see in multiple choice in bound up all them working and thing, right? Nobody watching that. So what this gives us k to be, boy, k needs to be something like 8. Because if I did a little bit of theta there, guys. So I was watching the answers and see which one plugging in here will give me 6. And if you're good in arithmetic, this really helps. Like I'm throwing the 8 here and I see 6 minus 8 is negative 2 by negative 3, 6, 6. 8 is the way to go. Instead of me having to multiply out all of these things, I know the answer is in front of me. You can always plug in the answer to get it. The point 23 is at one end of the diameter of the circle whose equation is blah, blah, blah. The coordinates of the other end of the diameter is what? How you do this again, boy? I could plug in the answers. So what they're telling me is I have this, I have the center. All right, I have a few ways to do it. I have the plug in the answer, I have using the center and the radius. Yeah. Just using the center actually. So I know okay, so they're telling me this is 2, 3. But I know the center of the circle is from this, what? Negative 5, 1. How many of you all understand that? Negative 5, 1. So I kind of draw this bad because the 2, 3 should really be here. 2, 3. So on the next side, because it's going backwards. So it gone back a good bit and you need to go back even more. Y'all understand how we're going to find this? You understand? If this is 2, the same distance here must be the same distance here, you know, to the center. So it went from 2 to negative 5, so you need to go back by a 7 again, so it go into negative 12. So I show about negative 12. And it's 3 here and it go 1, so it going down 2. So you need to go down 2 some more again, so you go down to negative 1. The answer is B. Yeah, the center is... Hold on, did I mess up this? Oh my gosh. I messed up this so bad. Thanks, boy, pledge. This is why I need to have 2 ways to get to the answer. You know? This is the center, 5, negative 1. So did I draw this the right way then? 5, negative 1. This is 5, negative 1. I forget to flip the sign earlier. Forget to switch the sign. 2, 3 would be about here. So 2, 3. So yeah. So I need to, and it's so interesting. It's so interesting that they had the wrong answer waiting for me. Wow, that was scary. Yeah, maths paper 1 is really Pete. So we're doing the same thing, but we're doing it in reverse. So it went from 2 to 3, so it needs to go up another 3, so it'll go to 8. And it went from 3 all the way to negative 1. That means it dropped 4. So you need to drop another 4. So you go to negative 5. So 8, negative 5 is the answer. Wow. And the next thing you want to do, which would have saved me with the next part of this question, is to take this and substitute it back in there. So take 8 and negative 5. So you can make a little asterisk, so it might take some time to substitute. And make sure that it equal to 0. So when it's equal to 0, you know, yeah, for sure, okay, that is indeed a point on the circumference of this circle. The vector A is given by that, a unit vector parallel. So I want the square root, 5 squared, 25, 144. So you want to divide by the magnitude. The magnitude is the square root of 169, which is 13. You all understand what I did just there. I got the square root of x squared plus y squared. So, and I need to divide by this. So this is the answer here. And that one is a quickie. Given that the vector AB, so this is AB is equal, this is straight up the triangle law, OB minus OA. So this is negative 17. Oh, wait, 4, 5, 4, 5. My bad. So this is 4, 5 minus negative 17, 25. So I'm seeing it has to be positive. Yeah. So D is the answer there. Straight up triangle law. Position vectors, the angle. So the angle is the dot product. So I want OA dot OB over the magnitude OA and OB. And the cos of the angle is equal to that. So the angle is equal to the cos inverse of, when I dot product, this is what happens. 2 by 3 is 6 plus 5 by negative, negative 5. So this is 1. 1 all over. Right? Looking like A is just the answer. All right, let me double check in case a negative sign or something had pop up. magnitude. Magnitude is what we're working out now. So this is the square root of 4 plus 25 multiplied by the square root of 9 plus 1. So you understand I squared one time. I just square them, right? So the square root of 29 by the square root of 10, which is the same as the square root of 290, which is A. So these questions, this is the first time we put on the Casio for a little bit, for a little 3-4 questions. It's no shortcut really to this. You have to know the rules surrounding vectors and um, circles and coordinate geometry to do these things properly, right? If sine of theta is equal to 513, so theta is obtuse. So meaning unit circle, theta is on this side. This is theta. It's obtuse. But the sine is equal to 5 over 13. So I have this here being 5 and this here being 13. So opposite, this is the alpha, opposite over hypotenuse. You had to know trigonometry to understand this fully. And this is a 5, 12, 13 triangle based off of your Pythagorean triples. So then we want to find the tan of theta. The tan would be, well, this is actually negative since it went backwards. So the tan of theta is opposite over adjacent. So I'm looking at 5 over negative 12. Answer is B. So that's the quick way to do this. You need to understand your unit circles. All right, cos of A plus B plus cos of A minus B. What are we looking at here? Cos of A plus B is really cos A, cos B minus sine A, sine B, plus cos A, cos B. Am I doing this correct? I think so. Plus sine A, sine B. So this gone, this and this will merge up. So I get 2 of this. I will get D as the answer. All right, so we started reaching back into a spot where you could actually verify your answer again. You could use back your Casio to verify your answer. In case you forget how to use trigonometric identities, you could choose 2 angles, so A and B. You could say let A be 10, let B be 20. And you could find the cos of 10 plus 20 plus the cos of 10 minus 20. Figure out what that is. And then double check each one of these and see if it works out to give you the same answer you get here. Understand? It's a form of theta. So I'll just do the answer so you can see what I mean. So like if I have the cos of 10 plus 20 is 30 minus plus the cos of 10 minus 20. So this is the cos of negative 10. So I get 1.85. 1.85. So now I can just do 2 my cos of what I say is 10. 10 my cos of 20. 1.85. So I know my thing working. You understand? I substitute values for A and B, some random values that I just picked. And it's supposed to work out. The others will give you 1-star whack answers. That is not 1.85. It pays to be able to know how to do those things. The graph of y is equal to sine 2x is, so sine 2x. So this means it's seeing ahead. In other words, all right, if I give you the graph of sine x does this. This is 2 pi, this is pi. You know what? Let me show you it on decimals. So you can know it once and for all now. Y equals sine x. This is the graph of sine x, guys. Now I want you to pay attention what happens when I do. I wish I could put this in terms of pi. I wish I could turn this in pi, but this is pi and this is 2 pi, right? Y'all understand? They didn't tell me that, right? So pay attention what will happen if I put the 2 here. Notice how it double up. So now this is pi and this is 2 pi. You get 2 versions. Then pay attention what will happen if I put the 2 here. Notice how it get bigger now? It going up. But it keep the same size. So that's the 2 main things they test you at this level. At pure maths, they could go a little further. You can visualize what will happen if you use a fraction. It will go half. So this is 2 pi. So in other words, to get the whole thing, you have to go quite to 4 pi. Seeing it? If you understand type, I understand. So if I put 3 here, you'll expect to get 3 of them before pi reach. Well, yeah. 1, 2, 3. Before 2 pi reach. Yeah. So if I put the 2 here, double up. What else, boy? Like if I add 1 to it, it shifts. Like if I add 60. Oh, not let's use pi. So if I add pi to it, it shifts. Or let's say I add pi and 2. This is what this one really shows up in pure maths more than anything. But notice how this looks like cos. This is cos. 2 pi up there. This is cos, right? Isn't it? So I shift it by adding, I shift the phase. All right, enough talk on that. So I'll just make sure I mash up that question when you come in the exam. So 2x are looking for it to double up, which is this. Because watch, if I continue out with this, I'll get 2 by the time I reach the 2 pi. Yeah, you get formula sheets. The smallest positive angle for sine theta minus cos theta to be equal to 0 for this is we could substitute and check now. Oh, we could literally substitute and check by. So I could say sine of, we put this solely in radians. You could say sine of, we could substitute in the answer for this one, real sick. It just taking me a little while to type it because I'm using my mouse. Minus cos, not most, but quite a few questions you could substitute in the answer. And you'll be real happy that you know about that little trick. Pi on 6. All right, this doesn't give me 0. So what kind of foolishness is that? Let's put 4 here. 0. Pi and 4. Is there anything smaller here than pi and 4? This is not smaller than pi and 4, and this is not smaller than pi and 4. So pi and 4 is the answer. What do you think about that? What's your thoughts on that, people? So is there another way to do this question? Yeah, there's another way to do this question. You could solve it. Divide everything by cos, so you get tan theta minus 1 is equal to 0. Oh yeah, equal to 0. So tan theta is equal to 1. So theta is the tan inverse of 1. And you just find the tan inverse of 1. Quarter pi. A quarter pi or pi and 4. So you get the answer there as well. Or maybe I wasn't seeing to do that. Another way people might approach this is bring across the cos. So you get sine theta is equal to cos theta. When is sine theta equal to cos theta? So this is the next thing you just know. It's pi and 4. Sine theta is like this. Cos theta is like this. This here is pi and 4. So there's a graphical approach, there's a substitute the answer approach, there's a solve the equation approach. Railways, you could do this all, yeah. Railways. 45. Pi and 4 is 45 degrees. Yeah. So sine alpha plus 45 is equal to. So once again, you could substitute for this. Yeah. You could choose a alpha then. So we can choose like alpha is 30 then. And find the sine of 30 plus 45. And put in 30 here, see if that works. You know the drill. 30 here, see if they give you the same answer. I'm feeling tired, so I ain't feeling to do that. So what's the method they want you to do? Well, they want you to use the compound angle formula here, most likely. So how this works is that you'll have the sine of alpha by the cos of 45 plus the cos of alpha by the sine of 45. But the thing is, the sine and cos of 45 is the same thing. We just show that actually. The question before show that. So the cos of 45 is in radian mode. Don't mess up your life like that. Root 2 and 2. Root 2 and 2 is the same as 1 over the root 2. Eh? Please memorize this. Root 2 and 2 is the same as 1 over root 2. Because if I multiply this by root 2, I will get root 2 and 2. So anyhow, so yeah, so remember this is the same as 1 over root 2, so I could factorize this out. 1 over root 2 by sine alpha by plus cos alpha. And lo and behold, that's the answer there. That's the answer here, A. Physics, I'll be doing physics tomorrow starting from 12. You're doing a physics crash course. Free again. Free things. Convert 4 pi over 5 radians into degrees. Well, your calculator can do that. But understand that pi radians is 180. So really what they're asking is to find 4/5 of 180. Now think about it. 4/5 multiplied by 180, and that's the answer. 144. And that's the only answer here that makes sense anyhow. It can't be this, it can't be that. No way 4/5 is that. So you know the answer had to be B. That is free thing. The exact value of tan 150, once again, your calculator is just going to give you this. You see, when these questions were made, people didn't know how to use their calculator. Now, courtesy YouTube, this is negative root 3 and 3. Which one do you think is it? Negative root 3 and 3? Yeah, remember your calculator is rationalize the denominator. So get that root 3 back in the denominator, and you will realize what's going on. This is the same as negative 1 over root 3 is the answer. So people didn't know how to use the calculator good, so it was stressing. This is like a question that could stress out people, but it's easy thing, easy thing. So how do you do this question, boy? How are you supposed to do this question other way? Oh, oh yes, father. We have a few ways. 150. What is 150, boy? 150 is 30 less, so this is really 30. 150 is 30 less than 180. So what I want to say about it. So yeah, so this is like using the unit circle. This is what I expected it to do. You should know that the sine of 30, what the sine of 30 gives. Sorry, not sine, we tan. You should know what the tan of 30 is. Once again, I don't have this memorized perfectly again. I kind of lost my memory of it, but I can work it out. For 30, 40, 60, 90, you should know all the sines, the cosines, and the tan of that. But as I said, the Casio just have that day. Just have that day for you waited, ready and waited. So the tan of 30 is root 3 and 3, or 1 over root 3. So the tan of 30 is supposed to be 1 over root 3. So you know that, right? But the idea is ASTC is supposed to say, well, since it's in this quadrant, it's negative. So I want negative 1 over root 3. And that's how you're supposed to do this question. Understand? But once again, your Casio calculator can just handle that for you. Just don't forget, if you see root 3 on 3, that's the same as 1 over root 3. If you see root 2 on 2, that's the same as 1 over root 2. Right? Both of them are the same thing. Oh, wait, so you have yourself in an identity in the multiple choice, but it is a difference of squares identity. So when I multiply this by this, I get 1 minus cos squared x. I'm going to check it out and see. And then this will go into this, 1 plus cos x times. So I'll get sine x, 1 plus cos x. And then I'll get the sine x multiplying by 1 minus cos x. But I know 1 minus cos squared x is actually sine squared x, since sine squared x plus cos squared x is 1. So all I have on top now is sine x, and then I have sine x cos x. But then I have a next sine x, and then I have minus sine x cos x. So these will cancel, and I'll end up with 2 sine x. This is the most popular. One of these sine will cancel, so I end up with 2 over sine x. This is the most popular identity in CSEC Maths. This here is the most popular identity in CSEC Ad Maths. Most popular. You're almost guaranteed to do that in an Ad Maths exam in any paper, to the paper one. So y is equal to 5 minus 2x to the power 5, then dy dx is what? Oh, the way to differentiate. So to differentiate this, all right, reach differentiation, people. So to differentiate this, and I'll show you how to do differentiation on your calculator. If you know, if there's a way to do definite integration and definite differentiation on the Casio. So, and I'll show you what I mean just now. Anyhow, so to differentiate this, you'll have to send this down by 1, multiply by the differential in the brackets. So differentiate inside the brackets. If I differentiate inside the brackets, I get -2, right? And then also multiply by the original here. So you'll get -10 by 5 minus 2x to the power 4. So the answer is A. What's the other way to do this? The way to do this on your calculator is actually longer than if you could just differentiate. So to differentiate, press shift on that. You see differentiation here in your calculator. You can actually type it in 5 minus 2 alpha x. And we want everything to the power of 5. So let me go back and just enclose this in our brackets here so I don't end up in problems. So so we use the chain rule to differentiate this, but I use it automatically. And x is equal to, I just pick a random x. Let's say x is equal to 1. So it will give me an answer -1, -810. And all I need to do is check all of these with 1 and see if I get -810. And only one of them will give me -810. So that's definite differentiation where I pick an x. So I differentiate this when x is equal to 1. Once again, not much people know how to do that. So that's the next little trick you can add there. Tricks bag day. The gradient at x is this, and the curve is that. Okay. So we want to differentiate. So dy dx is equal to cos x. So this is the differential equation here, first differential. So this is aka the gradient equation, and then I substitute the value of x in this. So I really want to find cos of pi and 6. Make sure my calculator is indeed in radians. So you have to change your calculator between radians and degrees a couple times in the exam. Your first thing in your checkover should be, did I mess up any degrees or radians stuff? Shift pi over 6. Pi over 6 root 3 and 2. Root 3 and 2. 5 over 6 is equal to like 180 divided by 6. 6 goes into that 30 times. That's like 30 degrees. Root 3 and 2, the answer. Wait, somebody said the wrong thing. Did I do the wrong thing? Differentiate this. You get cos pi and 6 is root 3 and 2 d. I'll you get this one wrong? Yeah, d. So the equation of a curve is that the gradient function is what? Once again, you can do the definite differentiation style and substitute a number and check the same number in all the answers and see if you get it. Oh, let's plug in next just so. So what's next? But we can differentiate this using the product rule. So the product rule says u dv plus v dv du dx, sorry. So u is, this is on a little annoying, x squared plus 2. dv dx is 3 by x minus 1 and negative 2. Plus, since this one annoying, using the implicit, using the definite differentiation here might actually be nice enough. Am I doing the right thing? I want dv dx, I want u, dv dx, and then I want v. Du dx, so differentiate that, I will end up with just 2x. This is really x squared plus 2. So I'll just end up with 2x. And then I need to simplify this. So I have negative 3 here. That negative 3 was a little, was that supposed to be negative 3? No, sorry, that was supposed to be positive 3. So when I differentiate this, is x minus 1 to the power of 3. So it drops here, the 3 drops there. 1 joins the 3, and this goes to 2. So it's just 3. All right, so everything looking like everything there. So we just quickly move along. This is x minus 1 squared, x minus 1 cubed. From both of them, I could take out a x minus 1 squared. And this leaves me back with a x squared plus 2, all multiplied by 3, plus, I'll have a x minus 1 here, multiplied by a 2x. Whew, this leaves me the x minus 1 to be squared. So I'm seeing that it's not going to be that. I'll have 3x squared plus 6. This is the longest question we do so far. And I have 2x squared minus 2x. And I had to go through the whole question to get that it's going to be C. So x minus 1 to be squared, 3x squared plus 2x squared will be 5x squared. I have the minus 2x plus 6. That question was the longest question because they forced me to do working. They forced me to do it earlier. I wasn't too interested in doing this. I hate this question. What's going on there? Was there a faster way, boy? As I said, you could use the differentiation on your calculator, but you still need to substitute in all these numbers here. So it's still kind of annoying. Anyway, you're bound to get annoyed with that question one way or the other. Given y is equal to, but not hard, just you had to work out some stuff. Given y is equal to 5 sine 2x, then dy dx is, so we differentiate this, we get cos 2x, and then you multiply by the 2, because then you differentiate the 2x. And you also have the 5 there was mine in human business. So this is 10 cos 2x d. All right, we keep it pumping. Everybody good so far? The curve C is given by equation that the second derivative is given by, so we're going to differentiate this twice. Differentiating it once. Yes, you can use your calculator in paper 1 for add maths. This is really 16 to x minus 1, right? So this is negative 16x minus 2. And differentiate this again, we get 2, switch back to positive, 32 x minus 3. So who gave me this here? You gave me this. So this is 2 plus 32 over x to the power positive 3. So there we go. 40, we coming up to the end of the first paper. The value of a for which the root, how long we, like our 90 minutes, root a 0 x squared minus 5 dx. 50 over 3 is, I mean, you can use your calculator for this. Why are we switching signs? Because I was differentiating 16x to the negative 1. When I differentiate this, the negative 1 will come down here and mash up my positive sign. So I get negative 16, and this will go down again, negative 2. And when I differentiate it again one more time, so this one was dy dx. And this one was d2y dx squared. When I differentiate it again, the negative sign come back down and mash up the dance and turn it back to positive like that. But with the commutator 2 this time. So the value of a, yeah, so this one you're definitely going to use the calculator for this one and just do it really quick. Integrate x squared minus 5, and we're just going to plug in the answers. So this is 0, and this one was, let's try 5. 5 works. So you plug in the answer for this one, right? So what was the way to do this, boy? Without your calculator, it will take a bit longer. So definitely do this with your calculator and move on. Sure, shout outs get past here. I mean, what is that shout out? This is shout out Heidi. Yeah, but so we need to integrate this. We'll get x cubed over 3 minus 5x between 0, so 0, and something, a. So what we're really trying to say is when we substitute a into this, a cubed over 3 minus 5a, we're supposed to get 50 over 3. And even when you reach here, it would still kind of just use some substitutions to help your maths work out faster. I mean, you could do it another way to factorize all the a, get the a squared. Yeah, just plug it in a calculator and that's the fastest way to go. Fastest way to go. Integrate this. So they just want to integrate this. Nice. So to integrate this, what we're gonna do this time is add. So you're gonna add to the power. So it goes up to 5. And well, you know how the thing is go. You know how the thing is go, right? So like if I was differentiating this, right? If y is that and I was differentiating it, it would have come down here. The 4 would have come down here. 5. This would have dropped to 3. And I'd have still multiply by the differential inside the bracket. So that I'd have to multiply by 3. But since I'm integrating, this isn't coming down here. This dividing, not multiplying anymore. And you're dividing by the new power. So it's dividing by the 5. You all understand? So I'm integrating here now. I'm going back up. And also, I need to divide by the differential inside the brackets. So I also throw in the 3 here. So the answer for this is 3x minus 5 to the power of 5 over 15. That's the short way to do it. Don't forget the constant of integration. So the answer is C. The region Heidi is starting to overdo it now. What's going on there? Heidi. You could get block and thing for them kind of behavior. What is that? The region in the first quadrant includes y is equal to that. I'm going to Heidi y. Heidi, they add maths in and SEA maths. They gave me some SEA maths type. Yeah, yeah. Heidi, that was your first and final chance, right? Don't make me a bad out here. Oh go. Or some kind of something about yourself. So the region in the first quadrant, blah, 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 lines, blah, 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 the volume. So we want to integrate y squared with respect to x, and then hit them a little multiply by pi. That's why you find the volume between the limits 0 and 2. So it's important that we find they really ask you this question, boy. They are next week's a time question. Heidi, I done give you a shout out already, Heidi. We're really going on with you. Heidi, you're causing me to lose my temper. Heidi, come on, man. I'm not feeling good, Heidi. I'm not in a hundred, Heidi. I don't have the patience for this. Yeah, so what we're supposed to do is square this between 0 to 2 and you multiply by pi. And how is squaring this way? It's looking like a nasty question to do, boy. It's rotated. Yeah, squaring this looking like no piece. So definitely do this one on your calculator, right? Because who going and square that? So we integrating and we're gonna put in the x's here. I'm a calculator again. I'm like, oh God, give me a chance now. Why all these integration? Calculator, you will work when I say to work. All right, so yeah. Heidi, you see how you spoil my calculator? So you put alpha x minus alpha minus sorry, we don't have alpha here, we want 1 over 2, and now we want alpha x squared. Yes, you're supposed to square this, but I not really feeling the square out there. That looking like too much work. I just going to put it in calculator. But good luck, you could square that up and thing. And then hit him a little between 0 and 2, 0 and 2, and then drop a little pi on the outside there to make sure you watching the scene. A little pi right there, shift pi, bang, 4/15 pi. C. C is the answer. So with your calculator, you could do this in like 10-15 seconds. But without your calculator, you're going another square that way. I ain't really see no other way. I ain't really see no other way. You're going another x minus a half x squared. You're going another square, and that is not pretty. You're going to end up with, you understand? You gotta get the expansion there, you get some fourth powers and all kind of thing. Yuck! Why is this question here? The region in the first quadrant x enclosed by the thing. I sorry for people with no calculator, and this just going to waste the time. What is there a fast way to do this that I'm missing? I'd have a fast way to do this, boy. There's a full paper, 2 for 4 marks. All right, whatever, yes. Look what's going on, boy. Long time. So the region R is enclosed by the x-axis here. So once again, calculator. This time you don't need to square because you're finding area. For some reason, my calculator, you want to move around and thing as fast as it. My x is solely off here. Bring him back up again. Resurrect him. Calculator, take a resurrect. Yes, a while you was up, exam after exam, I needn't close you off. You're just up there. You probably needed a resurrect. So, boom. So, yeah. So, we're going to integrate this. Alpha x squared plus 2 alpha x minus 1 between the lines 2 and 1, 2 and 3, 2 and 3. So this is just a simple integration to the 1 over 3b. Yeah, so this one is area. So this one you just integrate y between the limits. So I just substitute and integrate between this one is volume. So if it's volume, you have to use this formula. You have to integrate between the limits, but you need to square the function first. Then put it in, then integrate between the limits, and also multiply by pi in the ending. Makano, what you mean how you split on your calculator? So you watch me put this in my calculator 2-3 times and now still asking me how you split in your calculator. You know you can just pull back this thing. And you know that, right? Makano. You get me some Heidi behavior here. So yeah, just press integration. Look at it right there. Look at it. So this one, integration. Now it must be definite. You must know the limits you integrate in between. And then you put alpha to get the x's. Alpha x square plus 2 alpha. Do it. The first time you do it, you feel kind of good, but you feel kind of good. And you put it to 2 and 3 there. Type it in. Feel the power to the 1 over 2. Last 2 questions. So we integrating sine x plus 2 cos x. Well, integral of sine x is negative cos x. Integral of cos x is positive sine x. So who gave me this here, boy? You plus c, right? Given that we differentiate this, and we get that. Oh, so they're telling you if I differentiate this, it will go to this. Meaning integrate this, you'll get that. So therefore, but they're helping you out here, but my calculator don't help me out already. I don't need your help, brother, man. 1 plus x. 1 plus x squared. So if you integrate this, what they're basically telling you is put in between 0 and 2 in x over 1 plus x. Understand? And so you'll end up with something like 2 over 3 minus 0. 2/3. 2/3, yes. Actually, yeah, it was faster to just use the little tip. All right, and that's the end of that. How will you feel about them 45 questions? The next sample paper we'll be going through faster. This took us an hour and a half. Next one, we're going to try and do in an hour. And I'm feeling kind of tired, but I wanted to do 3. So let me do our next one. One time. That's like break and thing here. So this expression this is a repeat. I'm not doing nobody repeats, right? 1 over x plus 3 expressed as a single fraction. So this is x plus 3 by x squared minus 9. For the repeats, I could still stick in what the answer was. D. Yeah, so x squared minus 9, x plus 3. This into that is x squared minus 9. Will come up on top here. And this into that, you get 3x plus 9. Ugh. A message from the dark side. They want me to factorize something here, boy. What kind of wickedness is this, boy? So I thought you were out one time. X squared plus 3x plus. Hold on, let me make sure I'm doing the right thing here. X squared plus is x squared minus 9. X squared minus 9. Oh, it was getting a little scary. It was getting a little scary day. So, right. And then this is, so I see a little future here. I see a future here, people. So what I'm saying is that you could factorize out x, you get x plus 3. Going and cancel out with this x plus 3 here. So you get x over x squared minus 9. So the answer is B. You get B. Yeah. Sweet. Given that f of x is this, then f of x can be expressed in the form what? Or how they want me to complete this square? Oh, they take me a little while to see that there, but I'm slowing down. So they want to complete. They want me to complete the square. So it have a few ways to complete the square. Wherever we float your boat, you can even use your calculator to complete the square. Take out the 2, you get x squared minus 2x plus 1. Half of that, square it, you get x squared minus 2x plus 1 minus 2 plus 1. You add in 1, you need to take back out that by really subtract, so you really need to add back in 2. So we get, in the end, you get x minus half of that is 1 to be squared minus 2 plus 3. So who gave me this? You. C is the answer. C is the answer. So you can complete the square in a calculator is, this is in the form a x plus h to b squared plus k. The calculator will give you negative this, because it will give you the x coordinate of the minimum or maximum point, and it will give you this. So so very quickly, to complete the square, one mode, you go on equation, you plug in, you press 3, and you plug in the coefficients. It's -2 is the a. Don't get type, eh? It's -2, not 1. Then -4, then 1. Then you press equal. Give you the minimum value, x is -1, so I know that this has to be +1. Oh, shucks. We're in a little pickle here. Somehow I select the right answer, but I had the wrong thing here. This should be positive. Because remember, I take out the negative 2, so this is positive, positive. Remember, I take out the negative 2 already, right? So positive. I get a little double checked here. So this is negative 1, so that means it's positive. Because remember, x is equal to minus h now. And then this gives me the k value, which is 3. So verified. Sweet, right? And they just give me it in a rearranged format here. If you understand type, I understand. So this is that. Look, the way to complete the square here again. More completing the square. So it's like a party then now. It's a papi show now. So we're going to put 1 day. And we're going to put negative 6 here. So anybody else hungry? Why? Oh, God. The after exam hunger. Again, imaginary numbers here, bro. For the roots. But we don't care about the roots. 3. So I know this has to be negative 3 since I get 3 on the calculator. And then k is 4. K, just read off that value there. So h is negative 3, 4, A remains 1, B is the answer. You all understand? Of course, I could complete the square the long way, pull out the A, half of that and square it. Half of 6 is 3. Negative 3 squared is 9. So I've created a perfect square. Of course, you could do the formula method if you only know how to do the formula method. Then you get half of that, so that's 3 again. Put that square there, but I added in 9, so I need to take out 9. If I take out 9, I will end up with just 4 here. So that's the answer. Boom, B. So let me keep it pumping. Number 5. Quadratic equation is such that the sum of its roots is... Oh, by the way, oh yeah, I did mention this already. This is the number to WhatsApp for the student hub. If y'all want the best you could get in online lessons, pure maths, add maths, physics, whatever it is you're going to do, yeah, WhatsApp that number and organize yourself for the next cycle. You would have find out these secrets long time and you had the right calculator a long time. The quadratic equation is such that the sum of its roots is this and the product of its roots is that. The quadratic equation is, well, the sum of the roots had to go here. So let me reconstruct this now. This is x squared. Sum of the roots will go here, but you'll switch the sign. 2/3 x. And the product of the roots will go here, but you keep the sign. And you notice how we have 3 and 4 here. We're going to multiply by the LCM of the denominators. We're going to multiply by 12. I say hungry and I lost. I say anybody hungry and I lost 20 people in the life one time. Anyhow, so 12x squared, are you going to eat all? 12 by this, the 3 will cancel, you end up with 4, so you end up with 8x. 12 by this, the 4 will cancel, end up with 3, so you'll end up with 3, 9. So this is the answer here, which is this one. Yeah, this is sum and product of roots. This is the alpha beta thing. You have to know the theory to understand what I just do here. The sum of the roots is equal to negative b or minus b and a then. And the product of the roots is equal to c or c and a then, if a is not 1, you know. And this is add maths. The set of values of x for which 3x plus 2 is greater than x minus 2. Did I do this already? Bring this across, you get 3x minus x. Bring this across, you get negative 2 minus 2. So you get negative 4. 3x minus x is 2x. X is greater than negative 2. We didn't switch any laws. So we just keep it like this. We didn't mess up anything. So you don't need to switch anything. No, you cannot spam. The values of x for which 3x minus 2, 2x plus 1. So if I multiply this by, if I multiply the whole inequality by 2x plus 1 to b squared, I will get 2x plus 1 by 3x minus 2 is less than or equal to 0. You'll notice I pick up the pace, right? So you'll get either 2x plus 1 is equal to 0 at the root, so 3x minus 2 is equal to 0. So x is going to be equal to negative a half, or x is going to be equal to 2/3. So that's the 2 points of interest for us. This is clearly a minimum point because the a is positive. 2x by 3x is 6x squared. So I'm going to put my negative a half here and my 2/3 here, and then I'm going to examine this. I want it less than 0. So I want the sandwich situation. I want it between negative a half and 2/3. Negative a half and 2/3. Call that time out there, my brother. This man didn't just type AFK. All right, Heidi, enjoy that food away from keyboard. Oh gosh, boy, Heidi, boy. Oh gosh. Heidi, this is not League of Legends. Oh, you get mistaken, Heidi. You thought you was on Twitch for a second. Heidi, how much accounts you really have, boy? Heidi, whip out all the accounts. Yes? Will you be able yourself? So, f of x, Heidi pronounces earlier. Heidi pronounce earlier and the earlier. Be able yourself now, earlier. Negative 2x, negative 2 over 9x cubed. What are we working for here, boy? This is f of x. Then, what in the world is going on here? Oh, well, it is an interesting one, eh? This is a polynomial, and these kind of polynomials is do this. And they want the range of values between negative 3 and 3. That's bacchanal. Well, let me try something here. Because sometimes you can be wrong in it now. Sometimes you think you get the range and you did not get the range. Okay, fine. Let me substitute negative 3 into this and see what happens. If I substitute negative 3 into this, minus 2/9 by negative 3 to the power of 3. You get 3 the Casio bless up. Negative 3 right out is negative 27. Bang, bang. And 9, I'm going into that 3 times. So we're ending up with here, a positive 6, a positive 6, right? Boom. Okay. Then 3 going into this, what are we going to end up with? We're going to have a positive 27, 2/9, 9 going into that 3 times, and you end up with a negative 6. So the range is like it go down to negative 6 and come up to positive 6. Use the range. Now I'm gonna put this in and let me show you the danger I was talking about with this kind of graph. Minus 2/9 x cube. Oh, I don't have a x squared or anything, so you're safe, you're safe. Right. Right, we safe. So the one between negative 3. So we see in here that negative 3 goes up all the way to 6. And positive 3 will go down to negative 6. So that the full range of values from that to that, from here to there, that we'll see. So yeah, we good to go. We good to go. The problem I was saying is like some of these graphs, if you have like plus x squared, like if you try to take a range between like let me say 1 and 4 or 1 and this number here, you might think it will get you when you say the range is from here to there. But lo and behold, in between there, it went up and come down, and it could do all kind of things in between the numbers sometimes. But since there was no x squared term, there was just this x cube, you're safe. You're safe. You're safe out here. Function, the value of f inverse of 1. Substitute the 1 to be equal to this to solve this kind of question. So x plus 1 is equal to 1, x is equal to 0 is the answer. Is the answer here. If I put 0 in this, I will get 1. 9 functions, blah, blah, blah. Didn't we just do something similar to this? This is f of x. No, this is g of x. G f of x. Take f of x and put it in g of x. So I'll have 4 plus 3 over 2x minus 5. Could make everybody come over the 2x minus 5. So this is 4 by 2x minus 5 plus 3. So this is 8x minus 20 plus 3 over 2x minus 5. 20 plus 3 will give me that. So I'll end up with this. X cannot be equal to 5 over 2, otherwise I'll end up dividing by 0. Which one of these graphs to pick a function? This is a function, passes the vertical line test. This is not a function. It doesn't pass the vertical line test. Does not pass the vertical line test. This is a vertical line, so it does not pass the vertical line test. It have there'll be more than one point that will cut. This has infinite points along this line, so no. So A is the function. The expression when simplified, is this a repeat? Was it B? This is a repeat, so I'm not doing this one. Repeat. Those of you all who just jump in, I could go back and check that. This is also a repeat. Was this 96? Repeat. Which of the following mathematical statements are true? This could be a little confusing. No, this is not true. You're supposed to add, so this is not true. If you divide, you subtract, same base. So this one is true. If you have the power, you can bring it down, so the B could come down. So this is true. So 2 and 3. 2 and 3, C is true. That's pure theory. This is a repeat again. Was it a quarter? This was a repeat. So this is 3 in a kind of way. 3 by 3 to the power of 3, 2x equal 9x. No, this is not a repeat. We didn't do this yet. Well, it is a repeated question, but we didn't do it yet. What am I trying to say with this question, boy? What is I trying to really do on this question? I'm trying to form a little. I could substitute answers. I'm trying to form a little kind of hidden quadratic sum here. Because this is really also 3 squared. So I have the 2x there. I have the 3 by the 2x here. All to the power of 3. 3. So I can let that equal to y. Wait, I'm overthinking this question earlier. I shut it down. I could solve it that way too, but I feel like there's a faster way. I could get like a same base situation working out here. A same base situation and just equate here. Yeah. I was overthinking the question, looking for hidden quadratics and all kind of thing. So what I could do is like do 3 by 3 to the power of 3. 3 to the power of 3 is 27, right? And you notice how that rail showing up in the multiple choice. 3 squared x. Bring up that 3, so I get 3. 3 by that is 6x. And the 3 come up there too, so I have 6x by a next 3, which is like how much ever x that is. This is 3 to the power of 2x. So 3 by 6 is just now let me take my time with that. I 18 also. It's in working out nice and all. Again, scary things happening here. 3, 6, 3. 3 cube 2x. 3 by 2x is 6x. Bring up the 3. 3 by whatever, yes. So yeah, so at the end of the day, 6x by 3 which is 18x is equal to 2x. So I figured out how to do math. So I want to say 9x is equal to x. Nah. What is happening? So this is 3 to the power of 1 multiplied by 3. Oh, shucks. I think in logs. All yeah, I was doing real shipping is 3. I apologize for shutting down there. This is 3, 2x I was doing logs and bringing up the power. I was doing logs and bringing up the power. So yeah, so this is 3, 6x. Okay, 3 to the power of 1 is equal to 3, 2x. Right, so this is 3, 6x plus 1 and multiplying, so you add the power. So what I was doing was, as in logs mode, there was short circuiting there. I was bringing up this 3. Yeah, so my bad, my bad. And is equal to 3 to the power of 2x. So 6x plus 1 is equal to 2x. Nice. This is it. 4x equal to 1, -1, x is equal to -1/4. That's the answer there. Now you can always substitute in the answer. You can do a theta for this. So like you can put in -1 here. Hold on, let me make sure I do this correct. 6x plus 1 is 2x. Bring across the 2x. You get 4x. Bring across the 1. You get negative. I get -1/4 there. I get negative. Well, again. Anyhow, so we can do this theta. So let me show you. So like we can say 3 times 27 to the power of 2 times, and we get a quarter, -1/4. So that is really -1/2, right? 1 over -1/2. Let's put a negative. And that is whatever that is. And then we want 9, 0.577. 9 to the power of and since it work out to be the same thing, we know we dealing with the correct answer is B. So the sum of the first n terms in a GP is given by that. For the series, the common ratio. All right, let me see if I can catch back myself here, because that's kind of, you know, what times I do this question in life, like maybe 400 times. And for some reason, I was thinking logs. So I'm tired. So the sum of the first n terms of a geometric series is Sn, now 400 times, so like about 10 times or so. Sn is equal to that. For this series, the common ratio is -1. Okay. So let me substitute now. S1 is equal to 4 to the power of 1 minus 1, so that's 3. S2 is equal to 4 to the power of 2 minus 1, so that is 15. S3 is equal to 4 to the power of 3 minus 1, so that is wherever that is, 60 something, 63, maybe. Maybe, I don't know, I don't really care. So 3, 15. Common ratio is -1. So the common ratio, the sum of the first n terms of a geometric series is that. Okay, let me just double check this again. So this is the sum, so it's summations, right? So this is the series, the sequence would be 3, then 12, then 15 minus 3 is 12, 63. Then somebody asking what I'm doing. No, I'm finding the okay. So S1 will be 4 to the power of 1 minus 1. So 3. So the first term is 3. The second term, the summation, is 4 squared minus 1. So this is 16 minus 1 is 15. But if I subtract, the term will be 15 minus 3 is 12. And the next one is 63. But 63 minus 15 is 48. But I don't want 63 minus 15. I want 63 minus 15 plus 3. So I wonder if they make an error in the question as well. Oh, that man in the future. That man in the past. When you see this, Makano, refresh your stream. Right now you're watching old things. Refresh your stream. Come up to me. Now what's going on? You understand? And now senior comments popping up here. So yeah, so I was saying, boy. The common ratio is not -1. So something wrong with this question. I think they want you to think is this, but I think they forget to minus the 3. This should be correct. So 3 should be correct. S2n is 2 4n minus 1. If I put 2n here, I get 4 squared. I can rearrange this. I could put 2 squared. Yeah, so this is correct. This works. I can rearrange this. If I substitute 2n here, this is the same as 4 to the power of 2n is the same as 2 to the power of 4n. That's fine. So this works. I think they wanted you to pick 2 and 3, but the problem is there's an error with this part here. There's an error with that part. So it have an error in this question. Error in question. The only one that works is actually 3. But they want you to pick 2 and 3, but unless I'm not seeing something. 3, 15, 63. 63 minus 15 is 48, but it's supposed to be 63 minus 15 plus 3. And or is it 63 minus 15? This is the sum of the first term, sum of the first. Oh yes, this is sum of the first 2 terms. I was thinking it. This is sum of the first 2 terms. So subtract. Yeah. So the answer is C. Answer is C. Answer is C. So this is cumulative. So this is first term. This is term 1. This is term 1 plus 2 included in the 15 here already. Yes. So subtract. Okay. Wow. So once again, this is sum of 3k is equal to, k is equal to 1. I was not understanding how it was written here. 1 over k. Right. So you could work this out. So you could get 1 over 1 plus 1 over 2 plus 1 over 3. And just solve that really fast. You could also put it in your calculator. So I know it's going to be a number bigger than 1. So it most likely is D. Because I have 1. And then after that, a half and a third. So a half and a third is what? 5, 6. 5, 6 and 6, 6. So 11, 6. The common ratio of the geometric series, so I want 12 divided by 8 and then 18 divided by 12 should give the same thing. Whoo! 4 into this 3, 4 into this 2, 3 over 2. D is the answer. We're starting to speed back up. The sum, while we do this already, is 600. The coordinates of the center of a circle, so the radius is 6. The center will have to be 1 and -3. C. Wow, there will be some speed questions here, boy. Points of intersection of the line here and the circle there. All right, so we're going to substitute points with maybe the line, not the circle, because 3 and 1 squared will always be 10. So we're going to use the line to see which one will work out. 3. So we're going to theta this question. 3 minus 1 minus 2. 3 minus 1. 2 minus 2 is 0. This works. And -1 minus 3 minus, this not working. This not working. All right, so we know this one working. 3 and 1 working. 3 minus 1 minus 2. That work. So don't throw away that one. That one working. Why do you want me to throw away that one? All right, let's try this. 3 and -1 minus -1 minus 2. This don't work. This starting to look a little scary, boy. Answer is D. 3 and all right, this is 1 and -3. All right, yeah, this don't work either. All right, so this works. So the answer is D. Let's try this last one. -1 minus -3 minus 2. Yes, equals 0. So this works. This is a popular question. Yeah. H2O, thanks. I switched up the X and the Y. It's supposed to be Y. It's supposed to be X and Y here. So this one don't work either. So all of these don't work. The D works. So D is the answer. The line Y is equal to this and the line that intersect at the point. So once again, Just double check and see which one works. 4 by, make sure when you're writing, so 8 minus 7. Yeah, so this one is working with that, but let's see if it works here. 4 plus 3 by 1. This one works. A works. 8 to 6. 8 to 16. This one doesn't work. Negative 10. This doesn't work. 0. This one works here, but does it work here? 0 plus, nah, it doesn't work there. This one works in the first one, but not the second one. So the answer is A. So theta really working out really strong for these kind of questions with the intersection. Point of intersection, just working out real fast, rather than having to solve the simultaneous equation. Vectors I and j represent 1 kilometer east and north respectively. So that is I, that is j. A man sails a boat such that is minus I. There's a current of 3I. So I need to add 3I to this. So it's 2I plus 2j. Easy things. Easy things. Well, I do a maths paper 1 yesterday, and I'll do a next one. I ain't settled the date on that yet. I'm doing a physics tomorrow from 12. I ain't settled the date on the maths yet. I didn't do it either Monday or Tuesday. After Wednesday, I may not be able to do anything except comment. Two vectors are equal if they same magnitude, same direction. Nice, nice. Is there any errors in the bio paper? The position vector of 2 points A and B relative to origin O are boom and bang. The modulus of AB and the angle AB makes with the x-axis respectively. Somebody I know some people keep saying I had an error in the bio question. I'll find the answer to this. Let me just check up on something here. I didn't see nobody talking too much about the errors. Oh, they did ask about nicotine and we talked about that yesterday. Yeah, we talked about that yesterday, Mr. Keeley. So the modulus of AB and the angle, two position vectors. So we need to find AB. You need to find AB. There's no doubt about it. So AB is OB minus OA. Let's find this one out yet. Minus OA. So this is 8,5 minus 30. So this is 5, 5. So that angle of 45 degrees. And the modulus of that would be the square root of 5 squared, square root of 25 plus 25, 50. So C is the answer. If it's 5, 5, that means it's going up like this, with the angle of 45 degrees. Trigonometric expression, sin x, we do this already. What it turned out to be? No, we do one similar to this. You're going to end up with 1 minus cos squared x here. Tell you, this is the most popular. And no, we do this. D, we get D. I think we get D. The sin x them cancel out, we get D. As I repeat, the figure M or N below shows a quarter circle, the perimeter. Radius is 4, 4. So we had to add 8, and we had to add this here. The perimeter of a circle, they look like they're using normal things. So the perimeter of a circle is you could use a couple ideas to find the arc length here, but this is pi on 2. And it's r theta, right? So r is 4 by pi on 2. 2, 2, so you get 2 pi. So this is 2 pi in terms of its length. So this is 2 pi plus the 8, or 2 into pi plus 4 could work as well. So the answer is D. This is the arc length. So 2 pi and you add the 4 and the 4. Repeat. So this will double up, or they bring it in a different way, but it's C. It doubles up like this. I went and showed you this on decimal, so I remember I showed you the graph. Smallest positive angle in radians, which in the range, blah, 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 to satisfy this. Oh, this one a little different by earlier. But once again, you could see to this question. A man using pen paper multiple choice. You could see that you could substitute the answers and see which one work. What I want you to do here, boy. Excuse me. So I don't think they want you to expand this back out because then you will add the factors again. So it's either cos theta is equal to positive a half, or cos theta is equal to 2. So this one is invalid anyway. Because when I equate to 0 now, I remember solving these trigonometric equations, what happens in the paper too. So I want theta is the cos inverse of a half, and whatever that is, yeah, is my answer. Pi and 3, pi and 3. Pi and 3 is the smallest man there anyhow. I can double check if pi and 3 would work in this by substituting it back. The exact value of, well, you can put that in your calculator to be honest. Cos of 5, and I'll show you all how to do the long way already. 5 pi on 12, make sure you calculate in radians, is root 6 minus root 2, a quarter of it. B. In radians, so 160, so this is what, 20 degrees, so this is 20 over 180 by pi, so this is 19 pi, pi over 9. So B. If sine x is equal to s, then cos 2x. So this is a very interesting question. So you can do this question using a triangle idea. Watch. So you could call this x mature and fighting. I might have to make a little move there. Sine, so s call this 1. You understand? Like this is s over 1. The hypotenuse is 1. So sine x is s over 1. So this here, my boy over here is really what? He is really 90 minus x, right? Agreed? Or instead of working out that, I could work out what this guy is here. So this is, remember, 1 squared has to be equal to s squared plus whatever that is squared. They call it x. So x is really 1 minus s squared. So this is really 1 minus s squared via Pythagoras theorem. Are everybody following so far? I'm going a little fast. I use Pythagoras theorem to find the adjacent side. Why am I doing that? Because cos 2x is really, there's about a couple ways to find cos 2x. What is the double angle formula? So we have sine 2x, we have cos 2x. I could even use the, sorry for the yawn there. Let me show you all here. This now. Where I could put this. So I could use any one. So cos 2x is really cos squared x sine squared x, or 1 minus 2 sine squared x. My goodness, I could have used the 1 minus 2 sine squared x. I didn't need to go through all that stress. So cos 2x is 1 minus 2 sine squared x. So cos 2x is 1 minus 2 sine squared x. So I could just say 1 minus 2, and sine x is s. So this is s squared. So I could have just jumped down to c real fast. I could use the other stuff as well with this 1 minus s squared here and it can work out. This is real neat, boy. This question is a cool question. You could do a lot of proofs using this idea. All right, let me keep pumping. Sine alpha. Did I do this one already? Alpha minus 45. I think I did, I think I did. Okay, me. Oh, this one is minus, this one is plus. So in this one, we got positive. So this one is minus. So what we do with this, we get sine alpha cos 45 minus cos alpha sine 45. But the same thing, the sine and cos of 45 is the same guy, this one. So this time we'll use the minus sign. So it still look out to be A. All right, keep it pumping. If f of x is equal to sine 3x minus cos x, then so we want to differentiate twice. We reach into the differentiation style. So differentiating this, we'll get for first derivative, we'll get cos 3x, and then we need to multiply by the 3 minus 4. It will change to positive because it switches the sign when you're differentiating cos 4x, right? So it switches the sign like that. And when you go down, the sign will switch again. This will be negative 9 cos 3x. This one will remain. So you'll get 4 by 4 is 16, and it goes to cos 4x. So we need to find this, which is not here. Ah! Wait, did I switch? I didn't switch. I didn't switch it to sign. I didn't switch it to sign. I didn't switch it to sign earlier. Did I say sign and right cos? Because remember, I had to switch. Right, so it's D. All right, so 36. The curve C has the equation f of x. C has a stationary point minus. This is how I end up on memes and TikTok and thing. Like, oh god, oh god. Minus 2, 5. If the f double prime x is equal to this, then okay, I don't know how to do it. I need to read this over. The curve C has this. It has a stationary point at negative 2, 5. Oh, so they give you the second derivative and they give you the point. So you're going to substitute to find the nature of the type of point. So when I substitute x is negative 2, I'll get negative 2 to the power of 4 minus 16. Negative minus 15, sorry. So this is 16 minus 15. So this is positive. And since it's positive, we can expect a minimum point. So C, why will you say D? Negative 2 going in here, I guess 16 minus 15. If it's positive, you expect a minimum. If it's negative, it's a maximum. So C. I'll get C. C is the answer, right? Verify that. So we want to differentiate this. This is a quotient. So U is 2x minus 1. V is 5 minus x. And if I differentiate this du dx, I will get 2. dv dx, I will get negative 1. So, what I want to do, that's not, I'll see if there's a faster way. All right, so v squared v du dx minus u dv dx. I just want to substitute and hope for the best here. All right, so I end up with 5 minus x. Du dx is 2 minus u. My dv dx is -1, so -1 by dv dx by u is 2x minus 1 over v squared. 5 minus x to v squared. This will simplify to give me 10 minus x plus 2x minus 1. I see a kind of 9 situation happening here. Positive 9 and did I leave out a 2 here? Positive 9 and the x's cancel. Positive 9 and the x's cancel. The answer is A. So I'll end up with 9 over 5 minus x to b squared. So real signs, the real watchy signs when you're doing this question. And if you could come back and double check it using the method that I show you, this is the method where you put shift, differentiate, and you put in the whole thing. And you just substitute a value for x now, minus 1. And then you put 5 minus x. And let x be like x is 3 or something, or 2, let's say 2. So you get 1. So now you want to substitute 2 into this and make sure you get 1. So you get 9. 5 minus 2 to be squared is indeed 1. 9 over 9 is 1. 1. So it works out. So you know that way you're sure now. And in case you had make a mistake with the sign, you'll be like, oh shucks, it ain't working out. So you know to go back and check, and you might realize you leave out a negative sign or some kind of thing. The point P, 1 lies on the curve, blah blah blah. The value of the gradient. They reuse this. The value of the gradient, right? So this is a case where you could use you could directly use this because you see you know what x is. X is 1 and you have the y. So instead of having to differentiate a whole quotient rule again, you can do this. You can watch it again. I'm doing this from the start. Shift that fraction 3 alpha is how you get to the x minus 2 all over 2 alpha x minus 1. Put x is equal to 1, press equal, and you get the answer 1. The gradient is 1. Good stuff, right? And you can differentiate it and do the long way to find out for sure. Given y is equal to 2x squared plus 3 sine x, then dy dx is what? So you're going to differentiate this, so you get 4x plus 3 cos x. Sine those switch for this one. So the real testing you on trigonometry. There are some questions here that I didn't do, and I'll try to do some. Maybe if I'll try to squeeze in one more math session where I'll do like some of the new style of questions that they bring in any multiple choice. They bring in some kinematics questions now. I'll try to do like a couple of them. But other than that, we covered a lot of questions today. Integrate this, and we got 6. So if we integrate this and we multiply by 4 and add 5, well, that's literally multiplying it by 4 and then add 5 outside of that. So you multiply this by 4. 6 4s are 24 plus 5 is, so the answer is 29. So this is just testing to see if you understand how integration works. The region enclosed by the x-axis, the curve, blah, blah, blah. Was this a repeat? I think it's a repeat, but let's just do it nevertheless. So this is integrating between, so I'm going to put negative, use this sign for negative, don't use the minus here, always use this for negative. Squared plus 2, 0, 2, 1, 5 over 3, B is the answer. Keep it pumping. I think this is a repeat as well. So this goes up to 4. You divide by the 4, but also 4 by 2 is 8 plus k. You also need to divide by the differential of what's in the brackets. So this answer is B, and 43 is the region bounded by the curve y is equal to 2 sine x, the x-axis and the lines x is equal to 0 and x is equal to pi is revolved about the x-axis to form a solid of revolution, the volume. So we need to square this, so that'll be 4 sine squared x, because the 2 will square as well. We'll integrate this between the 0 and the pi, and we'll also multiply by pi. So who is giving me that? You are. So that question then asks you to work out anything. Just see if you know the format. Not this one, because we need to square it as well. Hold up, eh? Am I wrong? 4 sine squared x. No, look, the part 2 here and a 4 there. This is wrong. This is wrong. See? No, this is wrong as well. You understand why I get this, right? I square this. So when I square this, this is 2 sine x by 2 sine x, which is 4 sine squared x. I need to integrate this between the 0 and the pi, and then I need to multiply by pi. So if there's anything, I could get 4 pi, 0 pi sine squared x, but that not here. So is either this or this. So the answer is A. If this then integrate that, so they want us to integrate, so we're going to get 3x to the power of 3 and divide by 3 now, plus integrate cos x, you get sine x. 3's will cancel, so it's x cubed plus sine x plus c. Right, so that's B. Some really easy questions coming on here, but the integral of cos x minus 2 sine x. So integrating cos x, you get sine x again. Integrating sine x, you get net, the sign will switch, so this will switch to cos x. So you get sine x plus 2 cos x plus c. D. So how are you feeling? We not much people here in the AdMath session. You know, AdMath is a kind of limited amount of people. Are you ready to go on to sample 3, or are you good day? Or hit them our next one. We have been going for like about 2.5 hours, 2 hours, 20 minutes. Are you good day? Are you go and practice the rest by yourself? Go back to number 42. So yeah, you get to see all the calculator tricks. 2x minus 4 to the, yeah, so add 1, divide. So if there's anything, feeling to take a break, I feeling tired, I feel, your answer is D for this one. Let me just double check. Oh, look, I put 8 here in a circle there. Sorry about that. Sorry about that. Sorry about that. We can get the documents, search online, bro. No. I can't tell you more than that. Search online. See if you can find it online. See, you know, I don't want TX here on my back now. So what else, boy? Yeah, so I could probably come back in another time. So tomorrow, I'm coming in to hit them some physics. Tomorrow I'll be coming in from 12 p.m. from midday. We're gonna do some physics. I want to probably do maths. I will probably do maths on Sunday. Maybe maths. A long session of maths, maybe I might start like around 3 p.m. or something. Your calculator is supposed to be safe. So they're not supposed to play mad and take away your calculator. They do that in a couple of schools. And then maybe on Tuesday, Monday or Tuesday, I could swing back. I want to do some chem. I want to do some physics again. I want to do some maths, add maths again, and some more maths. So everything has to happen before Wednesday. So Monday, Tuesday, I'm coming back in with 2 more sessions. So we can decide. All right, people. Love and blessings. So I can see you later tomorrow. We can pick back up with some more physics. If I get some energy, I don't know if I'll come back in tonight self with some stuff. But we can see. Love and blessings. So we have sample 3 to go. All right, good.